In this section, we are going to discuss our next topic, which is also address resolution protocol. In our previous section, we have seen the communication between same subnets. Now, today we are going to see the packet flow when we have PCs into different subnets. So we have this simple topology wherein we have router 1 or R1, which is connected to PC1 with Ethernet 1/1, and it is connected to PC2 with Ethernet 1/2. The IP address of PC1 is 10.1.1.1/8, and it has the default gateway address, which is router 1 Ethernet 1/1 IP address, which is 10.1.1.2. The MAC address of PC1 is 00000001111. The MAC address of interface 1/1 of R1 is 3333. The MAC address of interface 1/2 of R1, it is 4444. The IP address of router 1 interface 1 by 1, as you can see, it is 10.1.1.1.2, which is also the gateway for PC1. And the IP address of router 1 interface 1/2 is 20.1.1.2, which is the gateway for, you can see, PC2. The IP address of PC2 is 20.1.1.1/8. Default gateway 20.112, which is the IP address of router 1, and the MAC address of PC2 is 2222. So the question is that when we ping from PC1 to PC2, how many ARP packets will be generated? Let's find out. So when there is no communication, let's see what are the ARP table of router 1, PC1 and PC2. So you can see here the PC1 ARP table, which is having the IP address and MAC of PC1 only. PC2, it is having the IP address and MAC address of PC2 only. Router 1 knows about the IP and MAC of its own interfaces as of now before any communication, right? Also, you can see here the routing table of router 1. It is having the subnet of 10/8, which is connected through Ethernet 1/1, and it is having the subnet or the network of 20, which is connected through Ethernet 1/2. Now let's try to ping from PC1 to PC2. So from PC1 we are going to give the command, right, ping, and then the IP address of PC2 20.1.1.1. So as soon as we ping from PC1 or we give this particular command, ICMP protocol is going to generate the echo request packet, correct? So let's fill out this information, and so the echo request packet will be generated, right? And as we discussed in our last section or previous video also, that there will be a type code for echo request, which is 8. So this particular information will be generated by the ICMP protocol for the echo request. Then ICMP is going to hand over this particular information that is just created to IP at layer 3. And now IP is going to take action on this particular information, and it is going to add extra information at its layer, right? So let's see what are the different information it is going to populate. So it received ICMP echo request, and also, as we discussed in our previous section as well, each layer they are going to keep a track of information that is provided to them. So it is going to populate the protocol field for ICMP, because this particular information is given to IP by ICMP protocol. So the protocol number for ICMP is 1. Then there will be the source IP. The source IP is 10.1.1.1, right? We have the destination IP, which is 20.1.1.1, and also there will be TTL field. Okay, so there will be TTL field based upon like if you are using the Windows, or maybe it will be 128. If you are using the Cisco iOS, it will be 255. So we are just mentioning, okay, there will be TTL field. So this is the particular information that will be generated by the IP protocol, right? So now let's move to our next slide. So now IP is going to hand over this packet to whom? It is going to hand over this particular packet to ARPA protocol, right? At layer 2. And now ARPA will try to create the frame. So, and as we discussed already, that the information generated at layer 3 is known as packet. So ARPA received the packet from IP or from layer 3. It is also going to keep a track of this information. So it is going to populate the type field for IPv4, which is 0x0800. Then see, the thing is, when ARPA is going to populate the source and destination MAC. So before this, an AND operation uh, is going to happen on PC1. So let's see first this part. If we go to the next slide. So PC1 is going to run an AND operation to find out if the destination IP which we are going to communicate is in same subnet or it is in different subnet. If you remember our previous video, there was the communication between same subnets. That is why uh, in that section we tried to find out the destination MAC. Okay, in our scenario, you can see that 20.1.1.1, which is the destination IP for PC1, it is in different subnet. That is why the rule is that if we are communicating into different subnet, then we are going to find out, or ARPA is going to find out the MAC address of the gateway, not the destination. If the destination IP is in same subnet, then ARPA is going to find out the MAC directly for the destination IP. Okay. So first of all, let's see how this AND operation works, or how PC1 is going to find out if 20.1.1.1 is in same subnet or into different subnet. So let's go to that slide. So first of all, let's see how the AND operation works in same subnet. So you can see that I have taken one example wherein we have an IP 10.0.0.1, which is having the mask of 255.0.0.0 or /8. So now when this particular PC is going to ping, let's say 10.0.0.2, which is in same subnet, correct? So let's see how the PC is going to find out if 10.0.0.2 is in my same subnet or it is in different subnet. So now you can see the first line, this one, this is 10.0.0.1, which is the IP address of PC1. Okay. And the second line, you can see it is the mask. So it is in 0 and 1's form. It is in binary 255.0.0.0. Now there will be AND operation between the IP address and the subnet mask of PC1, and we get this particular value. So one by one there will be AND operation. Okay, and now after the AND operation we got this particular result, which is 10.0.0.0. Now the result we got is this one, and this is the IP address we are going to communicate. Okay, now this is the binary form of 10.0.0.2, right? Now there will be AND operation between these two values. Okay, now you can see there will be AND operation between the result we got and the binary value of 10.0.0.2 or the destination IP, this one. So now we got the result, and the result is this one. 10.0.0.0. Now you can see that these two value, the first value which came from or which was derived from the IP address and subnet mask of PC1, we got 10.0.0.0. Now the result of this and the destination IP binary and operation result is also 10.0.0.0. It means you can see that these two values are same. It means now the PC will get to know that 10.0.0.2 is in my subnet or is in same subnet. That is why at layer 2 the ARPA protocol is going to find out the destination MAC. Now let's see another example with the different subnets. Okay, let me go to the next slide. So if you already know this particular operation, so you can skip this part maybe. So now let's see when we have PC1 which is having the IP address of 10.0.0.1 with a mask of /8. The destination IP this time is 20.0.0.2 which is in different subnet, right? So I'm not going to do the end operation for PC1 and the mask because we have already done it in the previous section. And we know that the result was this one, right? Which is what? 10.0.0.0, right? This is the result we got in our previous section for the PC1 IP and the mask. Now, this is now what was the next step? Next step was we got the result and then we need the AND operation of the destination IP binary also, which is 20.0.0.2. Sorry, 0.2. And now you can see the result here. The result we got is 0.0.0.0. Now you can see that these two results are different, right? That is why now PC will get to know that the destination IP, which is 20.0.0.2, is in different subnet, which means that ARPA is going to find out the gateway MAC. Okay, not the destination MAC, which was the previous case wherein the destination IP was in same subnet. Okay, now let's go back to our previous slide. Wait a minute. Now let's go back here. So we were at step number 4, wherein ARPA was trying to find out the MAC address, right? So the problem here is that if you remember in the ARP table of PC1, so in the ARP table of PC1, there was only the IP and MAC information of PC1 only, but there was no information of the MAC address of the gateway, right, which is 10.1.1.2. So now ARPA is going to take help from which protocol? It is going to take help from ARP, right, to find out the MAC address of the gateway address, correct? So the ARP or the address resolution protocol is going to generate the ARP request, so which will look like this. So the source IP will be what? It will be the IP of PC1, which is 10.1.1.1. What is the destination IP? Destination IP is the gateway IP, which is 10.1. Sorry, 2. Then the source MAC. Source MAC is what? 1111, which is the MAC address of PC1. Destination MAC will be all zeros, right? And there will be opcode field, right? This we already know in our previous section also. We have done this ARP operation for the same subnet. It is the same. flow. So the opcode will be 1, which is for the ARP request, because this is the ARP request packet. So ARP is going to generate this particular packet, and now it is going to hand over this to ARPA at layer 2, right? So now let's move. So this we have already seen. So now ARPA will try to create the frame, right? So it received the ARP request, right? And as we know that it is going to remember this particular information. So it is going to put the type code for ARP, which is 0x0806. It is going to check the ARP table and find out the MAC against the IP, which is 10.1.1.1, and the MAC address is 1111, right? And the destination MAC will be OLF, correct? So now, as we already know what is going to happen now, so ARPA is going to hand over this particular information to physical layer, and this particular information will be reached at router 1, right? So at router 1, the frame will be recreated, and ARPA is going to receive this particular information or frame at router 1 with the destination MAC OLF. So now ARPA is going to remove, so this particular frame will be accepted and layer 2 header will be removed, right? Now you can see once this layer 2 header will be removed, now ARPA is going to check this type field, right? This one. So the type field, there is a typo, so you can correct it. It is type. So this type field will tell ARPA that it needs to hand over this particular packet to ARP protocol, right? Now let's move ahead. So now ARP received this particular information, right? Right. So ARP will check the destination IP. So in the destination IP field, what is the IP address? It is 10.1.1.2. That is why this particular information will be accepted. Now ARP is going to check the opcode. What was the opcode that we populated? It was opcode 1, which means it is an ARP request packet, right? So from this packet, it will pick up the source IP and MAC address. So what was the source IP and MAC in this particular packet? It was the PC1 IP and MAC, right? 10.1.1.1, and MAC is 11111. So now ARP is going to populate the ARP table of router 1. So now the ARP table of router 1 will look like this. So it has its own IP and MAC for both interfaces, Ethernet 1 by 1 and 1 by 2. Now it also knows about the IP address 10.111 and the MAC address of PC1, right, against this particular IP address. Now, so so ARP already populated the ARP table, right, of PC, so not PC, of router 1. And now it also needs to generate the ARP reply against the ARP request that it received, right? So the ARP reply packet will be generated by ARP, and it will look like this. So the source IP will be 10.1.1.2, which is the router 1 IP address. The destination IP is PC1 IP address. Source MAC will be the MAC address of Ethernet 111 or router 1. Destination MAC, PC1 MAC. Opcode this time will be 2, which is ARP reply opcode, right? Now ARP is going to hand over this packet to ARPA. The same process will be followed. So now ARPA will try to create the frame at layer 2. So the frame will look like this. So ARPA received the ARP reply packet. It is going to keep a track of this information. In the type field, it is going to populate the type code for ARP 0x0806. Source MAC is 3333, right? What will be the destination MAC? Destination MAC is 1111. And now it is going to send this particular information to physical layer, and PC1 is going to receive this particular information. The frame will be recreated, and now you can see the MAC address in the frame is, or the destination MAC is 1111, which is the PC1 MAC address. That is why the frame will be accepted. Now layer 2 header will be removed, and again the same process will be followed. The ARPA is going to check the type code, which is the type code for ARP. It is going to hand over this particular information to the ARP protocol, right, or the address resolution protocol. Now ARP is going to check the destination IP. The destination IP was 10.1.1.1, which is PC1 IP. That is why this particular information will be accepted. Now ARP is going to check the opcode field. In the opcode field, it is mentioned 2, which means that it is an ARP reply packet, right? And in the ARP reply packet, it will find out that, okay, the information that I requested, which is the MAC address against my gateway IP, which is 10.1.1.2, is 3333. So PC1 is going to populate the ARP table with its gateway MAC address, right? So now you can see in this whole process, PC1 did the ARP for its gateway. One packet is already dropped, right? So when the next ICMP packet comes in from PC1, so let's see what exactly happens. Okay. So again, there is a ping from PC1 to PC2. So an ICMP echo request will be generated, right? What is the type code? Type code is 8. This particular information will be handed over to IP. IP is going to populate the information. So it received the ICMP echo request. It will keep a track of it. The protocol field will be populated. The protocol number of ICMP is 1. Source IP 10.1.1.1. Destination IP 20.1.1.1. And the TTL field will be populated. Now IP is going to hand over this particular information to ARPA protocol. So now ARPA will populate the information. So ARPA received the packet from layer 3. Now it is also going to keep a track of it. It will populate the type field 0x0800 for IPv4. The source MAC is 1111, which is PC1 MAC. And now you already know that because we are communicating in different subnets, so PC1 is going to do the AND operation. It knows that we are communicating in different subnet. So ARPA is going to check the ARP table for the gateway MAC, and we already have the gateway MAC now, right? Which is 3333. So the same information it is going to send to router 1, right? So the frame will be accepted because we have the MAC address of router 1 interface 1 by 1. So now at layer 2, the destination MAC was checked and the frame was accepted, right? So once the layer 2 header was removed, so this header will be removed by ARPA. It will check the type field. Knowing the type field, it is going to share this particular information to IP at layer 3, right? Now you know that router is going to check what? It is going to check the destination IP into its routing table, right? So we already seen the routing table of router 1, right? So it knows about the 20s network, which is connected via Ethernet 1/2. So before router 1 sends this particular information to PC2, there will be some modification. It is going to change this. You can see earlier the source MAC was PC1 MAC and destination MAC was the router 1 Ethernet 1 by 1. MAC. Now router 1 is going to change this particular information. So there are packet rewriters that works on the router. So the source MAC will be changed to the exit interface MAC, which router 1 already knows, right? 4444. And destination MAC will be the next hop IP, right? So again, the same end operation is going to be run by router 1 to find out the destination IP MAC address. I mean, to find out if the destination IP is in my same subnet or in different subnet, so that it can populate this destination MAC field. So the same operation is going to be run, and now because 20.1.1.2 and 20.1.1.1 they are in same subnet, that is why router 1 is going to check its ARP table if it has the information about 20.1.1.1. This particular information is not there into the ARP table of router 1. Okay, that is why now router 1 is going to follow the same ARP process to find out the MAC address of 20.1.1.1, right? So when router 1 is going to send the ARP request, you can see that in the ARP request it is going to send the source IPS 20.1.1.2, source MAC 44444, destination IP 20.1.1.1, and destination MAC all zeros, and all that process will be followed. When PC2 receives the ARP request, you can see that it can now learn about the MAC address against it gateway IP, right? Because when router 1 sends the ARP request, already the IP and MAC information is there. So now PC2 can save the information that, okay, my gateway IP MAC is 2222, oh sorry, 4444, right? So during this process, you can see now that the ARP table of router 1, it knows about the PC1 MAC and PC2 MAC also. And ARP table of PC2 will look like this. It knows about its own IP and also the gateway MAC address. You can see 4444 because router 1 sent the ARP request. So PC2 saved this particular information, right? So till now, there are two packets that are dropped. One was when PC1 did the ARP for the gateway. So from PC1 to R1, and now router 1 did the ARP, right? So now two packets are dropped till now. And now you can see these table. At this stage, the ARP table of router 1, it knows about its own IP and MAC for these interfaces, Ethernet 1x1 and 1x2. Also, it knows the IP and MAC of PC1 and PC2 as well. PC2, it knows about the IP and MAC of its gateway. Similarly, PC1 also knows about the MAC and IP of its gateway address. Now, when the third packet comes in, because two packets are already dropped, so when the third packet comes into router 1, right? I'm not going to describe the same process again. So we are assuming that everything is sent from PC1 to router 1, and now because earlier what was happening that router 1 was not, when router 1 was doing the modification of source and destination MAC, it was not able to find the destination MAC, which is PC MAC address. But because now router 1 already did the ARP process, so it knows the destination MAC address of PC2, so it can change the source MAC and destination MAC in the packet it received from PC1. So source MAC will be 4444 and destination MAC will be 2222. So using the physical layer, PC2 is going to receive this particular information. So frame will be accepted at layer 2 by ARPA because the destination MAC is 22222. Now you can think, or it is clear that if, let's say, earlier when the router 1 received the source MAC, the packet, there was, so the destination MAC was 3333, right, which was the router 1 Ethernet 1x1 MAC. Let's suppose the router 1 do not change the destination MAC, right? So router 1 is going to send this particular information to PC2. So what is the destination MAC that PC2 received? It received 3333, which is not the MAC address of PC2. That is why if router do not change the layer 2 header or the layer 2 information, which is the destination MAC of the next hop IP, PC2 will never accept this particular packet. Okay, or it is not going to accept this particular frame because the destination MAC is not of PC2. That is why the packet rewriter at router 1, it is going to change the source MAC and destination MAC. So now PC2 received this particular information. Okay, so frame will be received at PC2, destination MAC will be checked, which is PC2 MAC obviously, and the frame is accepted. Layer 2 information or layer 2 source MAC and destination MAC, that will be removed. So now ARPA is going to check the type field, which is the IPv4 type code, right? So this particular information will be sent to the IP at layer 3. IP will check the destination IP. Okay, what is the destination IP? Destination IP is 20.1.1.1. That is why the packet will be accepted. Now IP is going to check the protocol field, which is the ICMP protocol number 1. So that is why the IP is going to hand over this particular information to ICMP protocol. ICMP protocol is going to check what? It is going to check the type code, which is type code 8, which means that it is an ICMP request packet. So now ICMP is going to generate the echo reply packet. It is going to generate the ICMP echo reply packet, and it will populate the type field. So the type code for ICMP echo reply packet is 0. Okay. Now again the same process will be followed. ICMP is going to hand over this to IP protocol at layer 3. So IP is going to populate different information. It received what? Echo reply packet, and it is going to keep a track of it. The protocol field will be 1, source IP 20.1.1, destination IP is 10.1.1.1. Same process will be followed. It is going to do the AND operation. It will find out that the destination IP in different subnet. It is going to check the ARP table for the gateway MAC, right? So sorry, this process will be followed at ARPA, not at layer 3. So IP is going to populate the TTL. It is going to share this particular information to, or hand over this particular information to ARPA. So ARPA will receive what? It will receive the packet. It will keep a track of it. It will put the type code for IPv4. It will put the source MAC. Source MAC is a PC2 MAC, which is 2222. Now again the same AND operation is going to be run, and gateway MAC will be populated using the ARP table, which is 4444. And now the physical, using the physical layer, this particular information will be sent to router 1, right? So now router 1 will receive this particular information, right? So at layer 2 the frame will be accepted because the destination MAC is 4444, right? Now again the layer 2 header information or the layer 2 information will be removed by ARPA, and the type field will be checked, which is the IPv4, right? This particular information will be sent to what? To IP at layer 3, right? Let me remove this. So now again okay, let's go back to the previous slide. So we were discussing that the again router is going to check the destination IP, right? And before sending this information, it is again doing this. It will again do the same operation. It is going to change the source MAC and destination MAC. Source MAC was PC2 MAC, destination MAC was 444. Now it will put the source MAC as 3333 and destination MAC again the AND operation will be run, and because the IP 10.1.1 is same subnet for this particular interface, so the destination MAC is already there also in the ARP table of router 1. So the MAC address of destination will be 1111, which is PC1 MAC, and this particular information will be sent to PC1. So the frame will be rewritten at PC1 and it will be accepted by ARPA because the destination MAC is 1111. Okay. Now you can see that the layer 2 information will be removed, right? Once the layer 2 information is removed, ARPA is going to check the type field, which was what, 0x0800, which is the type code for IPv4. That is why ARPA is going to hand over this particular information to IP. Now IP is going to check the destination IP, which is 10.1.1.1, which is its own IP address. That is why the IP is going to accept this packet. Now IP is going to check what? IP is going to check the protocol field, which is the protocol number of ICMP, which is 1, right? So IP is going to send this particular information to ICMP protocol. Now ICMP is going to check what? It is going to check the type field, the type code, which is 0. It means that ICMP will understand, okay, this is the ARP, sorry, not ARP, this is the ICMP reply packet, and our communication will be successful this time. So the answer to the question that we started, that how many ARP packets will be generated when we ping from PC1 to PC2 is 2, because we know that one ARP packet was generated by PC1 to find out the MAC of gateway, and another ARP packet was generated by router 1 to find out the MAC address of PC2, which is 20.1.1.1. So this was all about ARP when there is communication between different subnets. Now let's see. Now let's test your knowledge. So I have a small quiz for you. So I have created just simple 5 questions. So let me know in the comment section how many questions you have answered correctly. So this was all about the ARP for today, and I hope you like this video, and thanks for watching.